So welcome to our next talk today. The Airworthiness and Maintenance Specialty Group is holding regular talks on relevant matters in relation to civil and military aircraft. So today we'll have a very interesting talk, I think, around military aircraft maintenance and airworthiness. My name is Kyriakos Kourousis. I'm the chair of the Airworthiness and Maintenance Specialist Group. First of all, some words about the society. The society is the only global organization which serves the entire aviation and aerospace community, both as a learned society, but also as a professional engineering institution. The society is independent, evidence-based, and authoritative, relying on a body of knowledge going back more than 150 years. We play a leading role in influencing opinion on aviation and aerospace matters through various means, including publications, social media profile, interaction with the government, and extensive events program. In terms of our airworthiness maintenance group, the group is concerned with all aspects of airworthiness and maintenance, and subject matters include design, production, type certification, continuous airworthiness management, and maintenance of aircraft and related components, and incorporates the personnel and organization involved with such products and processes. The group is led by a committee which provides inspiration and leadership strategies for the aerospace industry to consider. The committee assists the society with the development of the aerospace industry and its people. We organize events, visits, we contribute articles to the aerospace magazine or government consultations, and we welcome volunteers to get involved in planning or writing for any of these activities. And you can get in touch with us, and I will share that at the end of this talk through our email and our website. We also have a LinkedIn group. So without any further ado, I would like to present our guest speaker for today. A brief bio for Squadron leader Alex, who is a Royal Air Force engineer officer with more than 16 years of experience working in military airworthiness and maintenance management. Squadron leader Alex has held posts on a variety of frontline units and with the Defense Equipment and Support Organization in support of a variety of fixed and rotary wing aircraft types. This included leading the Tornado Continuous Airworthiness and Maintenance Management Organization to full approval and managing the evolution of the Typhoon Equipment Safety Assessment to support the duty holder construct and introduction of Centurion capabilities. He also served as a senior engineering officer on the RAF's largest jet squadron, and now manages the development of engineering training for the growing Lightning force. Alex is a chartered engineer. He holds a master's degree in aeronautical engineering from Bristol University and a master's from Cranfield University in military aerospace and airworthiness.
Good evening, everyone, and thank you for logging in. My name is Alex. I'm a Royal Air Force Squadron leader and an engineer officer, as Kyriakos has said. I do have a surname, but the RF has told me not to disclose this for security reasons on this kind of global broadcast. That makes me sound a little more mysterious than it needs to. I can assure you my working life is quite a long way from that of a secret agent. Anyway, I'm imagining some of you out there may know me already, in which case, hi. Anyway, this is part of a series of talks, and as part of the committee, I offer to lend some experience, really, and I've volunteered today to provide some reflections on nearly 17 years in the RAF, and in particular on the changes that I've seen with respect to maintenance and airworthiness management of fast jet aircraft types. I'm going to keep this at the level of an overview without getting deeply involved in the technical details, although we can discuss the effect that new technology has had, as well as organisational and regulatory change. I hope this provides interest for you all. If you do have questions, as Kyriakos says, we can go through those at the end, and I'll do my best. Equally, there may be experts out there already, and you may like to help me clarify or correct anything. Please do message that as well. So Kyriakos has told you a little bit about myself, fairly kind of traditional entry route into the Royal Air Force. I joined the Royal Aeronautical Society as a student affiliate while I was doing my MEng at the University of Bristol. Like a bunch of my fellow classmates there, I was sponsored by the Royal Air Force with a view to joining on graduation. I did this in 2004, completing a year's worth of initial officer training and then specialist engineer training at RAF Cranwell. So this talk's titled, fourth to fifth generation fast jets. My historical appreciation of aircraft goes a little bit further back than fast jet, than fourth generation. My first job or tour, as we refer to it in the Air Force, was at RAF Kinloss in Moray as a junior engineer, or Jengo, on the Nimrod maritime patrol aircraft. This was pretty fast, I suppose, and it certainly was a jet. It's powered by 4 Rolls-Royce Spey engines, and it was obviously a combat aircraft as well. Apparently had the largest bomb bay in NATO, as we used to tell the visitors. And over its time, it had been armed with nuclear depth charges, torpedoes, and harpoon anti-ship missiles. However, it was a conversion of the first jetliner, the Comet, so it could be described, I suppose, as a second generation at best. And I raise this because very sadly, during my time at Kinloss, we lost a crew from 120 Squadron on board aircraft XV-230 when it crashed near Kandahar in Afghanistan. Now, I'm not going to go through that accident, and there have been a number of lectures in the aftermath of this kind of watershed moment for airworthiness in the UK military. And I'd encourage you all to read the Haddon Cave review if you haven't done so already. I imagine most of you have. But you can also find speeches by Sir Charles Haddon Cave on YouTube if you've not had the pleasure of listening to those, or learned talks. They're certainly worth a watch. Anyway, from my point of view, seeing the incident aftermath at such close quarters, it led me to focus on airworthiness and system safety for much of my career to date. As I said, I studied at Cranfield in airworthiness, and I did some system safety engineering study at the University of York as well. So hopefully my practical reflections I can share with you from my in-work experience will be tempered with some of the theory as well. My work experience has been largely focused on the RF support to the conflicts in Iraq and Afghanistan, and then later in Syria. And I'm one amongst very many engineer officers whose working lives have been dominated by this effort, whether it's RAF stations around the UK or in headquarters, or like I've done on many occasions, deploying into the operational theatres themselves. I imagine there'll be some RF personnel online today, and but for those of you working or studying elsewhere in aviation or aerospace, hopefully I can give you a flavour of what RAF engineer officers do. This is a surprisingly wide and varied career field, but at the core of it is an ability to make on-the-spot airworthiness decisions to enable military operations. And in hopefully my last mention of the mighty Nimrod, I'll encapsulate this in the following memory of a Nimrod MR2 that's actually parked at Sea Airfield, which is Muscat International Airport. And you can see Dinger Bell, my crew chief, valiantly trying to jack the aircraft up with a hydraulic jack that's leaking and showing a picturesque oil slick beneath him. Anyway, to get back to the point, in 2006, I was deployed to Basra Airport in Iraq. We had a problem on Nimrod with the fuel system. I can't remember the exact details. I could have dug out the job card, I suppose, but following the fatal accident in September of the year, we had a continual series of inspections to carry out on in-service aircraft as the investigation slowly uncovered more issues. Anyway, the inspection we had been asked to do could not be done in the way specified because the arrangement of the fuel pipes did not conform to the configuration in the technical documentation. And this shouldn't have been a surprise to anyone. The Nimrod had a certain hand-built quality to it. So the instructions that were written by some much more experienced engineer officers back in the project team in Cambridgeshire did not match the picture that a puzzled 25-year-old in the middle of the night inside the rear end of the Nimrod and the dark of the desert, thousands of miles away, was actually seeing. And it was actually very dark because floodlighting your aircraft in the middle of an airfield which was targeted by a barrage of insurgent rockets every night, was a pretty bad idea. Anyway, there was no one more qualified than me, and I wasn't that qualified to look at this. And the Special Forces were demanding the aircraft available next day for a takedown operation on a major insurgency leader. And this was before proliferation of drones within the coalition. So anyway, there was pressure on. I had to decide what to do. I had a propulsion technician in my small team with me, but in the end, I made a time-bound, risk-assessed decision to continue flying whilst we sought some urgent advice. And that's the kind of essence, I think, the reason I'm putting this little story out there is why the Air Force needs degree-educated, professionally registered engineers who are also serving military officers on the spot to make airworthiness decisions on active operations. So, as I'll also describe, we've got a significant role to play in the longer-term management of the airworthiness of the UK's military aircraft fleet. So, as I said, this talk is not meant to be about aged maritime patrol aircraft in the desert. So I'll hopefully get back on track with fast jets, or even faster jets. So the generation kind of terminology, for those of you who aren't plane spotters, kind of revolves around similarly aged aircraft which share similar technologies. There's not an international standard as such that defines generations, but the RAF, as you can see on the screen, obviously started with the Gloucester Meteor, and then led to generations of fighters, second gen, such as the English Electric Lightning, as you can see there in that fantastic photo, not mine clearly. Third generation of fast jets, the Air Force include the F4 Phantom and probably you could say the earlier Harrier Marks as well. With then the fourth generation, apologies, my phone fell over. The fourth generation, including the Tornado, and also things like the Harrier GR5, GR7. Now, obviously, the Tornado has been the mainstay of UK combat operations for the second half of the RAF's century, the first century we've done. But after this, fighter acquisition, as you probably all know, got seriously expensive and slowed down, which kind of starts to spoil the taxonomy of our generations and takes us to Typhoon, which most people agree is kind of generation 4.5. This is the current workhorse of the UK combat air fleet. It's currently employed on Operation Shader against Daesh, or IS, so-called, and they've been doing that since 2015, taking over from the Tornado. And that's in addition to 24/7 quick reaction alert, protection of UK airspace, and commitments like the current NATO air policing mission in Romania. Similar technologies, Typhoon you can find on the Rafale or the Gripen or the Su-35. Clearly, if in the market, do consider buying a Typhoon. Clearly, still an excellent capability with a clear roadmap for growth in those capabilities. But I haven't got a picture, but as you probably know, the US leapt ahead with 5th generation and went to the F-22 Raptor, which employs technology such as sensor or data fusion and low observability, commonly known as stealth. Now, the UK, as you all know, has its own 5th gen combat aircraft now, which is where I'm currently working. Well, not on the ship, but I'm currently working at RF Marham in Norfolk with the UK Lightning Force, which operates the F-35B, which is the V-style variant, and the force is made up of both Royal Navy and Royal Air Force personnel. 617 Squadron, who I was talking to earlier today, currently embarked on HMS Queen Elizabeth, and social media, we believe they're just going through the Suez Canal. And prior to that, a very short time ago, they took part in operational Shader with operational 5th gen missions from the carrier for the first time. So this aircraft then provides a step change in capability for the UK. and it does that with an exceptional suite of sensors, data processing, and networking, and that's alongside low observability, allowing it to operate in heavily contested airspace. And this, when you combine it with the forthcoming weapon set, Spear 3, the MBDA weapon, Meteor in the Beyond Visual Range Air-to-Air role, and Paveway, AMRAAM, and ASRAAM, which are currently fitted, that's going to make it a very potent, very significant asset. So that is all very exciting, isn't it? But as airworthiness and maintenance engineers, these combat capabilities are the reason we have employment. That's why they pay the wages. But in terms of our professional interest, they're not our primary interest. So alongside the combat capabilities have been a steady progression in the technology surrounding reliability, maintainability, and safety. These all underpin the key property that we as RAF engineer officers are most interested in, that is availability. We certainly tend to work for pilots and operational commanders, and those guys are interested in how many aircraft they've got ready to go on the flight line. And quite right too. The nation, our nation and others around the world invested billions of pounds of finances in combat aircraft, and that is all to waste if we cannot generate air systems that are available, ready to fly and ready to operate their weapons, sensors, and data systems. But as with combat systems, the key path of progress for that maintainability and airworthiness has been data and computational power. And with respect to the generations of RAF fast jets, we've evolved from maintainer's diagnostic panel on a Tornado, so I forget the exact terms, probably someone out there can correct me, but it basically relied on a series of light bulbs, and those sometimes blew, so you first had to work out whether you had a fault or whether you needed a new light bulb. And I remember seeing this for myself when I was going through my kind of training and work experience, looking at Tornado, and then we went through to Typhoon with a downloadable portable maintenance data store. I'll show you a picture of that later, perhaps. And then an interface panel on the aircraft, which that's similar to Lightning. What that does is essentially plugs a laptop in. You can do that on the flight line. You can do that anywhere the aircraft is. But here's the key change. That allows you to immediately interrogate a global database for the most likely resolutions to any faults that the technicians encountered. So we'll look at these kind of aspects in my talk in a little bit more detail, and we can consider the impact on our professional practice as engineers. So I've still got the Lightning on the screen there. Let's talk a bit about that and that trade-off between operational capability and maintainability. The case in point is low observable technologies, and obviously I can't go into a lot of detail in an open forum that's going to end up on YouTube. But if you Google, it's widely reported that the maintenance of surface finishes and the outer mold line, as we call it, of an air system is a key importance when you're maintaining low observability. This has been the case for the F-117 and through the B-2 and the F-22, and it's now the case for the F-35. It's become easier, I believe, having spoken to my American friends, thanks to design improvements, tooling, and materials. However, it's still a very important challenge when maintaining fast jets. It's got some advantages though. So consideration by the design engineer of the need to remove our need as maintenance personnel to break into the outer mold line of the Lightning has actually led to our lives becoming slightly easier to some extent. It's led to careful consideration of some subsystem locations for access around the air system. These components that are most likely to be changed out by the maintainer or inspected are located in easy access locations to a reasonable extent, with undercarriage bays and bomb bays being key areas that can be accessed without disrupting that outer mold line, which of course incurs lengthy repairs. Those of you may be familiar working in the civil air transport world, the key difference, and I've worked on large aircraft, as I said, the key difference is to fix a large aircraft, you can quite often get inside it to get access. You can't really do that with a fighter aircraft. You've got systems densely packed in there. So access without having to completely dismantle the whole aircraft is really important. This was designed into Typhoon to some extent. That requires regular access, probably more than they initially thought, into the two avionics bays located in the fuselage, just rear of the cockpit. It's a reasonably lengthy process, requires a large number of fasteners to be undone, which creates an airworthiness hazard in itself. As the large openings have got the number of metal bonding strips around the edge, and these are for current of flow for lightning protection across the surface of the airframe. That's a requirement of a fourth gen aircraft, which is largely composite. Those bonding strips, they've got a habit of falling off and risk lying loose in the internal bay, and that's hazard needs controlling. However, what the designer gives, they can take away. And in relative terms, the F-35 on the screen there, it's got a big engine, slides right out the back, and it does seem to require more frequent removal for access compared to the EJ200 that's installed on Typhoon. So looking back at Tornado, in terms of slick engine replacements, then Tornado ground crews were the king of those, with engines in and out again in a small number of hours. That was a specific design requirement and support equipment consideration for Tornado. Became less important for maintainability for its fourth and fifth generation successors. With the EJ200 and F135 power plants, they're orders of magnitude more reliable. You don't need to take them out to fix them as often, if at all. The RB199, perhaps a little over complex in its kind of spool arrangements and quite a fair bit of maintenance. It still does for those operators. However, so that reflects a bit of an evolution of maintenance philosophy that we'll come on to now. Tornado, you can see here, stock photo, a bit old for me. It was designed and born into a Cold War Air Force. It was intended to be operated out of hardened aircraft shelters, not the big hang you can see there, with ground crews in chemical, biological, radiological, nuclear weapon threat, PPE, and collective protection. And faults at the front line were diagnosed through functional tests, largely carried out by exercising systems plugged into various pieces of support equipment, specialist test sets, and then traced back to the most likely origin by reference to technical publications and those good first principles of engineering that we taught to people at places like Cosford. And then what we tended to do was replace the most likely line replaceable unit, LRU, take it out and put a new one in, and send it back to second line for test, diagnosis, repair, and then you might send it up back for deeper strip at a third line depot, or maybe to the original equipment manufacturer. Some very old dirty laundry here. In reality, what would happen, especially in those first decades of service, is the most convenient LRE would be replaced rather than the one that was most likely to cure the fault, and that would allow the aircraft to get released for flight again. And often the fault will come back, and the process would start again. This was fantastic for industry because it fed a huge and expensive industry of on-unit maintenance bays and depots and factories across Europe. And as well as corrective maintenance, LRUs often had to be replaced as they reached the end of their operating life. So that is, the designer calculated the optimum time to replace a particular component before its likely failure. All that good kind of reliability analysis. And in case of structural items, inspections were carried out before you got to the likely kind of fly hours where failure might occur, go through cracking that was hazardous or unrepairable. Because such replacements or inspections required the airframe to be depanelled and stripped away to varying degrees, like you can see on the picture starting to happen there. You would group these into packages of work that could be carried out either at the squadron level, primary maintenance, we used to call it. That was known as first line or second line. Maybe those guys would be doing primaries, primary stars, minors, those kind of categories of maintenance. That would be done on the base, or even then at third line depots, particularly when you talked about things like major maintenance. And when you start to inspect aircraft, you tend to find faults. You investigate further, and you potentially repair those. In Tornado world, this was known as the dreaded emergent work. Is the absolute scourge of maintenance planners and fleet management teams, as it's by its nature is unpredictable, particularly as airframes aged. So in the 1990s, I think this is where the picture is, there was a behemoth depot built at St Athan, a massive hangar that was designed to carry depot level maintenance for Tornadoes, VC-10s, a large workforce of military and MOD civil servant technicians. And it was hoped, I think, that bring economies of scale and efficient systems of work. So like many things in the 1990s, it started down the road of privatisation. However, as I entered the service in the very early 2000s, we started to see a different avenue. That was the Defence Logistics Transformation Programme. So as a young flying officer, first rank, I remember being baffled by some very fancy infographics during a visit to Defence Logistics Organisation at RF Whitton. So they showed a kind of on-base factory with various windows, and LRUs would be coming out, and whole aircraft would be handed over to industry through these kind of windows, and industry would hand us back a working LRU, and they'd hand us back a fully maintained aircraft ready to fly. So this was splitting out the first, second and third lines of maintenance into so-called forward, the military bit, and depth. This transformation, we're talking about the organisational construct here, coincided with a number of other developments in the UK military aerospace industry. Firstly, companies such as BAE Systems, who I've worked with for many years, realised that when we got to Typhoon, with it in service, there wasn't a lot of design work to be done now, and they only had a relatively small part of the giant F-35 programme. So they need to diversify, survive. I'm pretty sure their senior executives would tell you that. And one way of doing that was to get into maintenance and support. So they could run depth, and they would leave the RAF to run forward, if that makes sense. This also fitted the MOD's agenda. In 1997, we had the Strategic Defence Review. The armed forces changed finally away from a Cold War mentality to that of an expeditionary focus, with 2003 invasion of Iraq being a case in point. So I kept being told as a very young officer, if you have a future in the RAF, you had to be relevant, whatever that meant, and you had to be an expeditionary warfighter. That didn't really fit the terms of reference of a technician overhauling hydraulic jacks in a second line bay or carrying out major servicings at St Athan. You weren't getting sandy, and you didn't have to carry a weapon. So many of these posts were stripped away from the RAF, and there was a round of redundancies. This, of course, handy for industry, who then had a ready pool of skilled workers to recruit at air bases like Marham, where I work now, which become home to these depth maintenance hubs. To confuse matters a little, this also coincided with experimentation by both industry and the service in lean production methodologies to speed up depth maintenance, originating from Toyota production system and their car factories. So this led to things like Harriers being hoverboarded around between workstations in a depth hangar. So my involvement with Tornado started properly only in 2011, when I started in the Force headquarters in the Integrated Logistics Operations Centre, and I had a responsibility for capability management. So it's an effective joint fleet management operation with BAE Systems, who by this time had been employed under an availability contract. This effectively handed over the entire RAF Tornado fleet to their custodianship, with a payment made in return for delivering an agreed number of aircraft for the squadrons to maintain at front line and use on operations. So this was undoubtedly significant success, and a cause for one of the MRAeS very few praiseworthy National Audit Office reports. Billions of pounds were saved. And that's the NAO saying that. Another effect of this arrangement was industry was now incentivized to help us manage reliability more efficiently. If we kept sending back those LRUs, you can see getting stripped out into servicing at depth because they were the quickest things for us to change, then we would bankrupt the contract. This led to a focus on reliability engineering for engineer officers and the more senior technicians. So some excellent work was done through things such as PRISM reviews, which are kind of workshops which brought together designers, maintainers, and aircrew to talk through pre-intractable reliability issues. When you've got those people in the room, that often led to very simple modifications or changes to procedures that brought about significant benefits. So senior engineer officers, CEngos, on squadrons also became the unlucky recipients of bulletins informing them of how many times they'd changed the same component without actually fixing the fault. They came back a few times later. And literally that would happen, 13 or 14 or more times in a row. So once we had that data pushed to us on squadrons, CEngos had some very awkward conversations with the chief engineer on station, CEng, and dispatch reliability, mission success, and all costs gradually and significantly improved. And I saw that as I moved on to work in the CAMO. So the benefits of these new support arrangements were not total. However, industry can never recruit sufficient cheaper staff locally to work at out of the way air bases, and the RAF relied on loaning back a large amount of engineering workforce to make the operation work. So whilst long-term contracts based on agreed assumptions made for great headline savings, I think what we found with Telic, with Herrick, and with Shader operations, the reality of combat in those places meant that assumptions ended up going out the window, and the RAF had to make payments to make changes to fleet plans, which is fine. You pay for what you get. Of course, industry were never willing to commit to cover the risk of that unpredictable emergent work, so output was often very late. The squadrons did feel the impact. My particular role was to manage the constant swapping out of specialist equipment between aircraft, because we only had enough to service operational tasks and not enough, pods or add-ons in the cockpit to modify all aircraft to the same fleet standard. And they were prioritised for deployed operations. This obviously became easier as the Tornado out of service date grew closer and airframes were progressively scrapped with key items harvested back into the fleet. Another aspect of this organisational change was the all-encompassing role of defence equipment support. The big, kind of 6,000-7,000 strong organisation, the MOD, had contracts industry, and they held large sway over how the fleet was managed, how individual airworthiness issues were dealt with by instructions to squadrons and other maintenance organisations. However, alternatively, it could alter the technical publications, it could approve, it could certify modifications, and oversee their embodiment and contract for it. This was a far-reaching remit. Haddon Cave called it out, and a key recommendation was to establish a clear regulator in the MAA. It also fundamentally changed the way we managed airworthiness in the RAF, with the separation of type airworthiness from continuing airworthiness. With type left with DNS and those management individual aircraft in the fleet to the continuing airworthiness manager and their CAMOs in the frontline commands. So me, newly promoted, keen and armed to an MSc, this is where I came in, quickly found that the headline regulations made perfect sense in terms of dividing those responsibilities. But it made a very imperfect fit with the existing organisational construct, airworthiness management processes and contracts. So with Tornado CAMO, I began to manage. This led to a great deal of head scratching, lots of whiteboard diagrams, lots of fruitless attendance at other people's meetings. Because the issue was the new regulation made my boss, the MILCAM, accountable, but he didn't have responsibility for the processes. It's very difficult, and he didn't have control mechanisms to get things done they wanted. DNS was still issuing all of the technical instructions with their industry partners. In fact, we worked out for Tornado that there's about 100 people across multiple organisations involved in doing the CAMO's work for them. Given the time left for the Tornado fleet to run down, a mass reorganisation, recontract was not really an option. So, fortunately, in my studies, I've done a look at the application of resilience engineering principles to the management of airworthiness. And this is all about using analytical techniques to map out the complexity of the airworthiness management system and then focus on the interfaces between organisations, physical systems and electronic systems. Excuse me. So, I'll talk about in Typhoon in a minute, but it does bring us on with electronic systems, which is a key point of difference between these generations of fast jets. Tornado cut part of its airworthiness records from purely paper to what's meant to be an MOD-wide system called LITS. It's only really ever a partial success, with only some data on components captured and aspects of the maintenance environment operating on different IT systems altogether. This built-in interfaces and reduced visibility of the fleet-wide picture. It was, in many respects, significantly better than paperwork, and that continued, that paperwork, to fill up literally a small hangar at Marham with archive boxes. What I found in my study is resilience of complex systems depends on the property of adaptability, and in human-based systems, this is dependent on part of the visibility of what is happening in other system elements, and then the ability of those individuals to act accordingly, shared picture. So in Tornado CAMO, we began collecting data on levels of maintenance deferrals across the fleet for the first time. It's allowed us to adapt, for instance, prioritising spares or equipment to hotspots, particular squadrons or operating bases. And the following idea was that we could anticipate the downstream effects of any disturbance in this complex system and prevent things getting out of control. An example would be a build-up of deferrals causing delays to the production line in the combined maintenance and upgrade hangar, and thus putting jeopardy onto the key modifications that we're rolling out and deploying to theatre. So, Typhoon, as you can see on the screen here, had the next generation really. It had a thing, or still does, an excellent system called the ESS, Engineering Support System. My role on 29 Squadron, you can see flying over Buckingham Palace here. ESS was a revelation. It allowed instant access to any part of the airworthiness record for 18 or more aircraft that I had under my control. Researching fault histories that would take weeks on Tornado took a matter of seconds. Before I started in that role, I actually worked for the Type Airworthiness Authority as the system safety specialist. And here again, data was key. What we were doing was constructing and maintaining equipment safety assessment, which was part of the duty holder's air system safety case. The key challenge was an in-service loss model. Tornado had done that based on accident data. Us looking ahead now is based on fault and event tree analysis that came from Eurofighter as part of the design safety case. And that demonstrated risks from various airworthiness hazards were controlled to acceptable levels, and the overall likelihood of aircraft loss was within a certification standard. So this was incredibly detailed, contained analysis of events that are incredibly unlikely. So our challenge was to adapt that model to something we could realistically update within service reliability and performance data. So it became a reference point for the duty holder whenever there was a cause for concern. For instance, we had issues with some avionic cooling duct, overheating potentially of components, which led to fleet-wide inspections. So all that was based on that data and adapting that design risk analysis in service. What we also tried to do is put a feed into the duty holder's bow tie risk assessments, which modelled kind of human factors and operating issues. So by contrast to Tornado, the issue of Typhoon was the volume of data and accessing it across all these different IT systems. So, and there we go. That's Polly there on the flight line at 29 Squadron, plugged into the aircraft. And a similar picture really with F-35, some American dude there. Famously, the F-35 program's got I had to look this up, the autonomic, it's called Logistics Information System, ALICE, It's part of the complete weapon system. It's received a lot of bad press. It's in my view incredible advance in many ways. So firstly, it brings together many IT systems that live on separate networks on 4th gen platforms. So for a start, it reduces the number of laptops and desktops you see on RF squadrons and the difficulty of deploying them out into theatre. It's co-host data. It's got simple advantages for the maintenance technician. Something as simple as cut and pasting a piece of reference material into your work order saves a lot of time. So the key thing, though, and this is the really cool thing with ALICE from my point of view. It's got a thing called the Automatic Fault Resolution System, or AFAS, and this automates a whole series of reliability engineering processes. You know, I'm talking rooms full of people here, taking weeks, and essentially crowdsources knowledge, makes that available to, you know, like that guy on screen, the individual technician on the flight line and the hangar. So based on fault symptom data, all other previous occurrences across the global fleet, analysed, and appropriate solutions are suggested in a priority order. This immediately, you know, it refers you to a bit of the technical documentation to carry out that repair. And immediately reduces the need to refer to, you know, the squadron T-bar guru who's seen it all before. They're difficult to find on a really young platform. It doesn't entirely remove the need to exercise engineering judgment, of course. For example, the engineer's got to balance the speed at which the repair can be done, logistics considerations, the likelihood of a fault being successfully resolved, and all of those factors. So it may not be the top pick you go for first of all. You know, if the second pick is half an hour and the top pick is a week, then a bit of judgment required. However, the central central collation and exploitation of data is already proving to be a significant improvement on earlier systems. So if we look then finally at the differences between maintenance policies on Typhoon and Lightning. So for Typhoon, quite similar to Tornado, and indeed some subsystems were just evolutions of those. The environmental control system works for a start. And it's got similar maintenance philosophy in a lot of ways. Difference is stretched right out, so nowhere near as frequent need to take it to bits to strip out and inspect. So there's still a need for a large scheduled maintenance facility on site at Coningsby, and yeah, the traditional kind of production line methodology, starting with removal of surface panels. It does generate emergent work, although I think at this stage of life it's a lot less than it was with Tornado. And there are modifications embodied in Typhoon maintenance facility. However, you know, 4.5 generation fighter, most major modifications are delivered through software upgrade. And as I worked on Centurion weapons fit, that can be done in a few days in a deployed environment. Lots of CD-ROMs to upload, and then you can use the capability straight away without the need to take the aircraft to pieces. So for Lightning, the planned upgrades will be very similar. Key difference is in terms of scale of investment, the UK is a smaller player in the large, enormous Lightning program. It's got its advantages. It's centrally organised, hopefully a more efficient airworthiness management system. How it does pose for both the, I know because they told me, the TAA and the MILCAM challenges of exercising the correct degree of control and oversight in line with UK MA regulations and our national priorities. However, we've got a number of UK officers, luckily embedded across the Joint Programme Office in the States, and they've been there for many years. So it's not insurmountable. I suppose the most significant difference is the Lightning and Lockheed's claim not to do scheduled maintenance, really. It's got a more extensive vehicle management system, HUMS, that takes a greater number of sensor readings and has more advanced monitoring and reporting. So for this reason, combined with the reliability analysis, Lockheed hasn't specified large scheduled maintenance packages. Simply not going to happen. I think we'll see in service over the coming decades whether this approach continues to be supported. Through a longer term lens, this obviously gives a potential saving over the lifetime of the system. Don't ask me about finance, so not my area of expertise. So I'm just looking forward to the next NAO report in a decade or so. By way of a summary, I suppose I'd pick out a few trends in military airworthiness and maintenance management as we move from 4th to 5th generation. The big one is obviously data gathering and data exploitation. And of course, my career, we've gone from warehouses with dusty job cards to a reliability and technical support solution available instantly instantly at a click of a mouse. And that's based on global data and some elements understand machine learning. So that's mirrored in the air system, health monitoring system itself, vehicle management system, and Lightning. Greater level of data, greater processing power, enables quicker and clearer self-diagnosis, and this improves availability, dispatch, reliability. And then, of course, as I've just mentioned, that fundamental shift from preventative scheduled maintenance largely to on-condition, health monitored component changeout. And that's the exciting thing, and it's due to get better. There are still pairs, as they're called, life encodes, which do require inspections, and some things like lubrication and things like that. But as I understand it, JPO's intention is those get phased out as they build up better reliability data. And I don't think that's going to completely put us in the maintenance and airworthiness world out of the picture, but I think it's certainly going to make our lives easier and allow us to exploit those kind of combat capabilities a lot better. So hopefully I've still got a bunch of you with me, and hopefully that's provided an insight. So from my point of view, last 17 years or so, what I've seen moving from the latter days of Tornado through some kind of back office experience and squadron experience with Typhoon, and now in my role when I'm trying to sort out the training system for Lightning at MRAeS. I hope that's been useful for you. And I don't know if we've got some questions now, hopefully not too difficult or controversial.
So thank you very much for the very interesting presentation. Your talk was enlightening in some important aspects. So I would like to introduce the Q&A session. We'll have a few questions already. So the first one, I don't know if you would be able to answer that. If you have any estimate for the cost per flight hour, or you have for the F-35, and how it compares to other generation fighter jets, if this is something you can answer.
I can't answer with any kind of official MOD position. All I can say is what I've seen in open source media. Certainly Lockheed Martin are claiming that is now becoming cheaper than fourth generation aircraft. I think you probably want to take the view of independent analysts, really. It's very tricky business trying to attribute cost per fly hour to military aircraft. What do you include? The base at RAF Marham has got a mess where I live. Do you include that? The cost of the chef. Do you include just the tires? Do you include the components? Do you include capability upgrades? So it's a very tricky area, and I don't have the figures. I'll get in trouble if I didn't have them, I suppose.
Definitely. So so the next question, sort of a comment question. So you mentioned that the transfer of second line depth maintenance to contractors provides efficiencies. However, do you feel that it caused the skill fade in service personnel's knowledge, and which subsequently had a negative impact on deployment with regards to fault diagnosis and other areas?
Yeah, probably to a certain extent, but that was, depending on who you speak to, deliberately mitigated by the placement of RF personnel within the contractor's workforce and then rotating them back through. So when I was on 29 Squadron, we had about 300 technicians, and a decent portion of those had actually been employed within the depth environment doing deeper strip. That was useful for mechanical technicians, particularly because they got to see areas of the aircraft they wouldn't have otherwise done. However, I think some of the first line fault finding is almost a slightly different skill set, and the guys have been on squadrons for years doing that, knew all the tricks of the trade, really. So maybe a bit different to older generation aircraft, where it's really handy to have someone who's experienced doing an on-site repair a particular component or battle damage repair. We don't really do that kind of thing on fast jets anymore. So not a straight answer, but I suppose it depends who you speak to.
Yeah. So another interesting question over here, a bit generic as well. So you mentioned that the introduction of the civil CAMO model in the RAF and the challenges on Tornado. How would you assess the current situation and what would you change? That's a broad question as well.
Oh yeah, well, there's a couple of years ago, the Airworthiness Maintenance Steering Group did a session on this whole day down at Hamilton Place, and I spoke at that along with some much more expert people. Currently, it's more effective than it used to be. So I think there was CAMOs like mine at Tornado, and others did some groundbreaking work on just breaking down all the barriers and trying to understand what it is we were doing. So in the civil model, it's really, really simple from my point of view. I think EasyJet, they've got a CAMO, that's at EasyJet headquarters, and the type certificate holder, is Airbus in Toulouse, the fly Airbuses, or is it Boeing's, whoever. So they're organisationally and financially independent and separate organisations. Tornado CAMO, there was a bunch of engineer officers working for the Type Airworthiness Authority, literally 100 yards across a road from my office, and I was running the CAMO, and I'd be posted over there for my next job, and they might come over here. So it's still organisationally complex in a lot of areas. I think for Lightning, those guys there, they just got a commendation for their work actually setting up the Lightning CAMO. I think it's easier to start from square one with a new organisation. What I really wanted to do for Tornado was, yes, it's obvious why they wouldn't let me, basically transfer a whole load of posts from defence equipment and support that were doing the CAMO work previously and stick them in a new office block, write CAMO on the roof, and then sort out our processes from scratch. And that'd all be really simple. But you never, when you're operating aircraft, you never got the opportunity to stop and start again, really. And I think that's the case for aircraft that have been going for some time. But the RAF's had a recapitalisation program over the last decade, so you've got lots of new aircraft, A400, Voyager, etc., who've had the ability to set up their CAMOs from scratch and operate things in a more sensible way. And just to close off that question, I suppose the MRAeS relatively recently updated some of the regulation, and it's kind of enshrined some of the things we were experimenting with. So giving the MILCAM procedural policy tools to do his job, so he's able to issue directives to tell people to do stuff with the aircraft. Because fundamentally, like an airline, a military force has to operate in a federated system. So squadrons, 617 squadron and an aircraft carrier now somewhere hot at sea, we can't tell them what to do day to day. They have to have autonomy to operate themselves and do those kind of CAMO duties. So you've got to flex the construct to something that will deliver your operations.
Yes, that was an interesting question. How you shift from the training missions to the operation, from the training mode to the operational mode is also a challenge. There was a discussion some time ago at a conference on how you manage risk from time to time. You have to change how you assess what exactly is defined as a high risk or a low risk operation. So that may have an impact again in airworthiness again. And in relation to, we have a couple of questions in relation to technology. So one here says that current developing technology talks a lot about the use of AI, artificial intelligence, I presume, to fly jets, drones, and so on. Where do you think the future lies for maintenance? An easier job than flying or not? Yeah.
Right. So maintenance is always going to be harder than flying because I've had to go in the simulator. Typhoon's pretty easy to fly. It's just shooting at the bad guys is the difficult bit. And in terms of technology, I think AI and machine learning in particular, going through those vast tracts of data we've got, in the airworthiness world is where we should be heading. And as I said, with AFIRS and ALICE, F-35 are well into that already. And I have formally suggested this through channels at work, having written the Typhoon technical data exploitation strategy, that there's no reason why fourth, 4.5 generation platforms can't be pursuing some of that already. It doesn't involve modification to the aircraft. It just involves a lot of IT work, and the data exists. It's well ordered. It's well structured, and I think we kind of know what we want to do with it. And I know the company BA at Collingsby had done some experimentation with some kind of commercial off-the-shelf AI technologies. Looking at trying to select a tail number that would be the most reliable for a particular mission set based on historic data. Maintenance planning also, I kind of started to push towards that, where this business of emergent work, I said it's unpredictable. Well, yeah, it's difficult, but if you've done a maintenance package 100 times on 100 different aircraft, when you get to 101st, you can probably do a decent job of predicting what you're going to find, and maybe you can get some spares on order, and maybe you can schedule the correct amount of kind of emergent work time at the end of that package. So I think there's some simple stuff we could be doing with AI technology and the big data that's out there, and I don't think it would cost an awful lot of money, really. The RAeS certainly got a transformation program called Astra at the moment, and that is looking at all those kind of things. So I'm hoping there's someone beavering away at that at the moment. We'll see some improvements.
Yes, I think this covered part or most of a question referring to data. So when you talk about AI, you have another set of questions talking about data. So this question talks about data analytic services coming from the OEMs. So would you foresee any future in exploiting or making use of this data in a better way and in a wider way, so we get more data in short? How we can make use of them? What is the your views or your experience from that area?
From the OEMs and I suppose at a component level, I don't know. I guess I kind of hopefully answered some of that already. I suppose a lot of it, I think, is doing some decent contracting, so you can align the OEM's interest with the operator's interest. So in the past, OEMs have had great revenue streams of us sending back components for inspection and repair that didn't really need inspection and repair. So if you can get the contracting right, you can incentivize the OEM to do the clever thinking and work for you. If you're all trying to push towards the same metrics in terms of aircraft availability and reducing costs. And I guess that kind of works with big companies like BAE. If they're both a design organisation and they're the support organisation. We saw that with Centurion. So this, I'm pretty sure, was in the press. With the Titan contract for Typhoon, the claim was that we save £500 million in support costs, and the MOD gave the Air Force the direct authority to reinvest that in the Centurion weapons fit. So the cost savings the company helped us do, the line goes, paid for the new weapons fit, and that paid for that design work up at Wharton. So if you can incentivize companies to work with you, then we can harness some of these technologies to get the outcomes we want, I suppose.
Okay, so I think we can close the question session. I have one last question, which refers to maintenance. It's my own question. So you have gone through different generations of fighter aircraft, and you have seen that we're moving more in one direction or the other direction. I'm referring to wing level maintenance, second level maintenance, and depot level maintenance. What is the current mixture or the mixture of second to depot level maintenance that you could be seeing in fifth generation aircraft? I was reading one of the accident investigation reports which was published by the U.S. Air Force, F-35, which crashed last year. And it seems that there are a lot of items on the F-35 which require depot level maintenance. So it opened up a question for me. So, when you have all these unsolved discrepancies or pending modifications that require depot level maintenance, is it something that it is because we have a lot of modifications coming out of a new aircraft, or is it something more of a contractual thing or technology which requires deeper level maintenance when something breaks or something does not operate or needs further validation at a more expert level? So what is your feeling?
So, I mean, the brochure for F-35 says we just do O+ maintenance. So we're meant to, the catchphrase is do all your maintenance in the shadow of the aircraft. So, for example, you pull the engine out, it splits down into, I forget how many modules, it's 6, something like that. You may take the front compressor off and you send that back to Indianapolis or wherever it goes for that depot level maintenance. And that's it in terms of the national kind of maintenance effort, which is very different to what we saw with Tornado, with that first line, second line, third line, at the MOBs and then back into industry. I think some accident report that was some particular problems. And all new aircraft types have had those, haven't they? And there's been inspections and things like that to resolve them. But I think we've essentially cut out, the RF had first line to fourth line. We've essentially cut out second and third line. So everything's either done on the squadron, which is handy when you're away on a ship for 9 months, or you just take the whole large bit of aircraft and send it away to somewhere in the States quite often.
All right. So thank you very much again, Alex. It was a very, very nice discussion. We had the talk, but the discussion was equally interesting, I think. And I would like to invite our attendees to keep in touch with the society, with our group, the Airworthiness and Maintenance Group. We have a web page, as you see over here. We have an email, airworthiness@aerosociety.com. We would like to have your feedback for any matter related to this set of talks or any other matter. And please join our LinkedIn group. For those who are not members of the society, we regularly post invitations for such events or some other interesting topics for discussion, including accident investigation, analysis, and so on. Everything that has to do with airworthiness. Airworthiness is a very broad field. So thank you again for joining the talk. Alex, again, I would like to thank you very much for your time and for giving us a lot of insight on this matter. And please keep in touch. There will be a YouTube video for this talk and for the other talk that was held on the 24th of June. There are more talks this year, and this will be announced through the media I mentioned before. So have a nice night and see you next time.